Concrete Fundamental Part 15, Portland Cement. Question: what is the purpose of calcium sulfate gypsum? Answer: for modern cements, the rate of stiffening of the cement paste should be controlled within limits to make the cement a useful product. If the reactions were too rapid, causing flash set, the concrete would stiffen too quickly. If too slow, the delay in acquiring strength would be objectionable. The initial rate of reaction should therefore be controlled. This is done by controlling the amount of calcium sulfate gypsum CaSO₄, or gypsum with anhydrite CaSO₄, added to the cement as it is being ground. Cement chemists believe that for each combination of raw materials and fineness to which the cement is ground, there is some optimum quantity of calcium sulfate that gives the best results for the product when used at a given temperature. That is, the greatest strength, the least shrinkage on drying, and the least swelling on wetting. This optimum changes with use of chemical admixtures. Manufacturers should know the requirements of their own material. A maximum limit is put on calcium sulfate in terms of CaSO. In current prescriptive specifications for Portland cement ASTM C 150 and blended hydraulic cements ASTM C 595, ASTM C 1157 is a non-prescriptive, purely performance-based specification for Portland cement and blended cements with no limits on composition. Question: are the hydration reactions and the resulting properties of the cement affected by differences in raw materials or proportions of phases in the clinker? Answer: yes. Increasing the proportion of lime to silica, for instance, increases the rate of gain in strength and also the rate at which heat is liberated. Also, the resistance of concrete to sulfate attack is generally inversely proportional to the tricalcium aluminate CYA content in the cement. ACI to 5R. Question: how does the fineness to which the clinker is ground affect the properties of the cement? Answer: increasing the fineness increases the rate of hydration of cement, which increases the rate of gain in strength and also the rate at which heat is liberated, as in Type 3 compared with Type 1 cement. ASTM C 150. Increasing the fineness of a cement also increases the amount of mixing water required to achieve a given consistency and reduces the amount of bleeding by the concrete. Question: what aspects of the manufacturing process affect the properties of the cement? Answer: the essential phases in the clinker are formed in part at temperatures immediately below that of incipient fusion as the clinker begins to cool. Thus, the rate of cooling is important. The proportions of these phases are controlled by the chemical composition of the raw materials fed into the kiln. The proportions of the phases and the fineness to which the clinker is ground control many of the properties of the cement.